when I open a package that makes available to use reflection, it's not available for compile time. That's the purpose of exports. So open will make it available for usage of reflections, not only on public, but also on private members. And I can, of course, use exports and opens that will make the class publicly available to use in a compile time, reflection, and reflection on private members. Okay, what about the JVM? The JVM is already modularized. So we can see here that every package depends on the Java base. If you decide to use, for example, Java Desktop, if you decide to use Java Desktop, Java data transfer, Java prefs, and Java XML, and of course, Java base will be imported. So there is always a dependency. You cannot have a cyclic dependency, okay? So one module can depend on others, and if you use a specific module of the JDK, that will bring all its dependencies. Okay, now my favorite time. So let's do some coding here. Remember that I said that I have this class here, util, okay, where I am only allowed to use this this class here, okay. I can use util just inside this source code of first. I have two projects here. I have the project first and the project second. And inside the project first, I have a util class that as an internal class, I am supposed to use only inside my first application. I am not using Java Modules yet. Okay, this is renamed as java.back. So I will just run Maven plain package. Oops. Maven clean package. But there's no, okay. I'm in the wrong folder. Maven clean package. This will compile both projects, the first and the second. And now that I have my my jar file inside the target folder, I can execute java-jar first.jar, and you can see, hello world, I am first util method called from new. Why it's saying new? Because I'm not using modules yet. Okay, so I will create my first module. Before that, let me show you something. No, let me create the module. Okay, so I'll just rename this as moduleinfo.java. So I'm exporting only con.rafabenavides.first. Note here that at this moment that I just exporting first, my compiler says that here in my second project, I cannot use this util class because it is in an internal package, and internal package is not exported. So let me try to compile here. If I'm not wrong, compile is allowed. No, it's not. Okay, hold on a second. Wrong folder again. So let me compile. I was able to compile, okay. So let's try to execute the second project. So java-jar second, and I need to specify in my class path the first.jar, okay. And it's, okay, let me see here. First con.rafabenavides.first.app. Class not found errors. So let me see here. second.jar con second app. Yeah, it worked. So why it worked while my compile is saying, my compilation is saying, my IDE is saying that I'm not allowed? Because when I use class path, you treat the application as a class path, okay? The way that I should use is to change class path to use module path. And here I need to specify the name of the module and then the name of the class. That will say, let me see here. Yeah, it said I am second, okay? So, but the other class con.rafaben.first is saying class not found exception. Why? Because I need to, that's a module, and I need to import the module here. So I need to say requires first. Okay, when I do that, I can compile. So let me do Maven clean package. Oh, con.raf, and here Maven is also prepared to see modules. So now that I've declared my second as a module, it's the compiler is saying to me, okay, in the second app.java, first internal is not visible because I have an import here, right? And that is not being able to be used. So the way that I can do is export also con.rafaben first internal, and I can export that only to friend modules. I can say that I will export only to second. So only second will be able to see my package. Let me go to the proper folder, Maven clean package. Now let's go to second target and try to execute. And now it worked. And instead of null, we can see that the util method has been called from the first method, from the first module, okay? What else we can do? Well, we can read the descriptors, for example, for debugging purpose. So I can do jar-d and watch the second jar that will read jar minus f dash d. So it's saying that second is a module that requires first, contains a package called con.rafaben first, and the main class is second.app. So jar minus d dash d allows us to read the module descriptor, okay? So we saw how can we restrict access to internal package in module 2, right? Because if we remove, if we don't export that, the compilation will deny access to that internal class. We saw how can we allow access to internal packages, to friend modules, by exporting that just to friend modules. Modules should not have cyclic dependency. So I cannot, for example, I am requiring first, but I cannot say here requires second, right? That will create a cyclic dependency. Note here, cycle exists in module dependency. Module second requires itself via first. Okay, so we cannot do that. What else? And also duplicate packages are not allowed. So you can see here that I have the first package, and here I have the second package, but both starts with con.rafabeni. Imagine that I create here a class test1.java, okay, just a simple class. And here I will create test2.java. So now I have the same package being used on both projects. Let's see what the compiler says. No problem to compile. So let's see what's the behavior when I try to execute the application. And here it says package con.rafaben in both module first and module second. Okay, so that's one thing that we can do. So let me remove this. Remove also this class. Now we have only the first and the second package available. We saw that instead of using Java-class path, we use the module path and -n with the module name and the class name, right? Okay, so let's continue because we have more things to do with Java modules. Of course, we can use JDEPs. That's another tool for debugging purpose. So let me see here. JDEPs and what's the format? JDEPs and the path and the jar file. So JDEPs second.jar. And it says, okay, module first not found. So where is the module first? I can use add modules and say where module first is located. No, it must be before classes. So let me copy this. Module first not found. Let me see if it's module path. Module path. Yeah. So second requires first and requires Java base because we are using the package java.io, java.lang, java.lang invoke, right? So when I'm using second, first and Java base will be imported as well. Okay. Now it's another great feature when you are using modules is because you can use JLink. Sometimes we need to ship our application together with a specific JRE version. I don't know how many of you have faced a problem where it's not really common, but sometimes it's happened that you need to execute your application on a tested and certified JDK. So we can ship our JDK using JLink. So for example, look here, I'm using Java dash version. I'm using Eclipse OpenJ9 version 14. And if I execute Java list modules, that will bring all the modules that's part of this JDK. Okay, so you can see the modules Java desktop, Java login, OpenJ9. Okay, and I can, of course, create a minimal JRE by using JLink. So let me use JLink here. So in this case, I'm using the following parameters here. I'm stripping debug information. I'm using compression. I'm removing header files. Okay, I'm removing manual pages. I will output that to a folder called minimal JRE. I will add the module second. okay? And the module second is in the folder second, right? So I'm creating a launcher that I will give the name here. Let me see, Rafael. It's a name for the launcher of the second module. And inside the second module, the app class, okay? And where I can locate where are the modules? Well, first module are here inside target classes, and second is inside target classes. So when I execute that, it will take us some seconds, and you will see that it created a minimal JRE folder. If we go there, minimal JRE, and do a disk utility and see the size, US, I think it's HUS. It's 100 megs, okay? Yeah, 50 megs in this folder, okay? What else? If I go here and execute Java --list modules, we will see that it will have a minimal JRE with only the Java base, first and second. Remember that I said here, just add the module second. Second depends on first and depends on Java base, so that's why both has been added. And plus, another parameter here is launcher Rafael. So if I look here, I have another binary called Rafael. That is just a shortcut for Java and execute my application. So if I execute Rafael, that will execute my application. So my JRE has everything needed to execute this application using modules, okay? And JLink only works if you declare modules, okay? And for the last, we can create tiny cloud native image using JLink and Alpine. So for example, I have here, let me show that to you, a Docker file that uses OpenJ9 as a builder image that will copy both jars to this container and run JLink to create a tiny JRE. Then I will use, for example, Alpine, which is one of the smallest container images, and then I will copy from this builder container my minimal JDK. Okay, and then I can just execute the application. I created the launcher as run, so I'm executing here run inside the minimal JDK, and that's really tiny. So let me show that to you. Let's go here. Let's delete this minimal JRE and execute Docker build with the tag test and using this Docker file. So JLink is running. Now, if I go here and get and run, for example, Docker image, grep adopt OpenJDK, we can see that adopt OpenJDK is 420 megs. But if I look for test that I just compiled, let me see here, test is less than 50 megs. I just compiled it 20 seconds ago. So let's execute this image, docker run -it -rm test. Oh, I still have the, I forgot to do a Maven clean package after I deleted those classes. So Maven clean package, let's run Docker build again. And run. Yeah, it worked. And you can see it's very, very fast and very lightweight and very tiny. Okay. If you want to have access to this demo, so you can try yourself and see all the configurations, this project is already available in my GitHub repo. Okay, so you can see the example of the Docker file. You can see the example of the Maven configuration to build using modules. Okay, and all the examples are here. Perfect. And plus, although it's the end of this presentation, keep an eye at the GraalVM, because GraalVM is a really nice project. And also, I ask you to follow me on Twitter. Go to Twitter, look for my handle, Rafa Beni, click on follow, and you will get more information, because I'm always producing information related to cloud native technologies and Java development. Okay, so now it's time for our question and answers. And for that, I will stop sharing my screen.
Hi, Rafael. We don't have... Oh, we have one question now.
Yeah, related to the publication of the video.
Yes, it will be published on the YouTube channel for the LOC user group.
Nice. So if we don't have further questions, I think we can just end the session. Is that right?
Yes, thank you all for attending this session. You can see the agenda at laoc.org for more sessions. Thank you, Rafael. We really appreciate your support. It was a great session. Thank you.
Thank you.
Bye-bye.
And bye-bye.